Okay, hello guys, welcome to our channel Abhi Karo Code, and we have got one problem statement, that is a student management system. So based on that, we have tried to solve that problem with the help of our curriculum, that is data structures. Using data structure, we are solving that problem. So basically, I have designed this. What are the problem statements and what are the consequences? Means why we are choosing this problem statement is that we will discuss now. So first, there's some point you can see on the screen left out here. Here my cursor is going here. So basically, this is the introduction, or we can say a short video explaining my project in 10 minutes or maybe less than that. So first, we'll start about assessing about the problem statements. Problem statement is like manual student data management is slow and prone to error. The main cause of that student management system is it is done manually, and it is taking so much time there. After that, paper record can be lost or damaged easily. We can, in any disaster, any another thing, the paper records are very crucial because it can go anywhere or lost or tear it up. So it is very uh, risky. So another thing is, for that we have some solution, that is there is a need for an automated system that we manage data student efficiently. Means the student data should be managed efficiently, and that should be automated. Means it doesn't require any person that daily enters, and we have to maintain that. Another solution for that is the system will allow of us adding, updating, searching, deleting of records. So basically, this four things is using has we will be using some of the data structure. I'll explain you afterwards what's that data structure is being used for adding, updating, searching, and deleting. So next we'll learn about the concepts we are using for this problem statement, and the concepts we are using for this problem statement is linked list. So first I will teach you, or I'll give you a short introduction about the what is linked list, and we'll see. So I have came to the Gigs for Gigs webpage, and by visually I'll try to explain you what is linked list. So basically, linked list is just like a node having head and pointer which is pointing to the next node. So in linked list there are many types. In that singly linked list we are learning currently on singly linked list. So singly linked list is fundamental data structure. As you can see, the nodes which contain data and field reference to the next link. So as you can see in the image, head head is a pointer pointing to the data one, and that next means one another pointer, next pointer is pointing to the next data, that is 2, and it is continuing, and the last is equals to none. So this is basically a singular linked list. In linked list also we have different operations, just like we see in the problem statement, that is up, adding, updating, searching, and deleting. So we will first insert. Insert means adding. So there are three types in that also. Insert at beginning, insert at end, and insert at position. Position means at required position. So now we'll come up with inserting at a node at front of a linked list. Means if you want to insert at the beginning only. Here we can see the good example by the graph. We can see by the diagram we can see how it is explained perfectly. So input x is equal to 1. So if you want to insert 1 here with 2, 3, 4, 5, 2, 3, 4, 5, 6 by the mouse cursor, you can see, so here 2, 3, 4, 5 is there. But if we want to insert one node, that is 1, so we will use insert at beginning. So insert at beginning is that, see, here first head was pointed to the 2, but we want that one node should be coming ahead of 2, so we use insert at beginning, and 1 is added here. Now in the similar kind of example, there are the previously there was 5 pointers. Now the pointers has been, now the nodes has been changed. Now the only 2 nodes are there. But again, also the condition is same, that we want to add one node. So currently we are doing the same things. There is a visualization. I'll show you here. So first, in first diagram, you can see this one is refers to the new node as state here, and that new node pointer is a head. So head is pointing to new node means head is pointing to new node, and that new node next is pointing to the data. Data of which? Data of another, that is temp. You can say we have taken a temporary variable. So head is pointing to new node, and that new node next is pointing to another node, and that way this is connected. If you go further, so see, now 1, 2, 3, 4. So 1 is inserted at the beginning. So this was the insertion at beginning. Now we will see insertion at the end. So what if we want to insert not at the beginning but at the end? So in the sequence of 1, 2, 3, 4, 5, we want to insert number 6. So we can't insert at the beginning, or we don't want to insert at the beginning. So we will insert at the last, that is 6 after the 5. So insert at the last. It is similar to the insert at the beginning, insert at the last. We'll see a visual representation, or you can say we will visualize for you. So the head is pointing to 1, then 1 next is pointing to next node until null. So if you want to add after 4 one more null, so what we will do, the null, which is the node 3, node 3 next null, the node 3 next is equal to null. So whatever the null is pointing, we will point that null to new node 4, and that new node 4 will not new node pointer 4 will be pointing to a null variable. Now what it does that the third, where you can see this arrow is coming downward, means the third next pointer is pointing to the new node data. So it is connected, means 1, 2, 3, 4. Now we can connect 1, 2, 3, 4, and this is called a insertion at end. Now at, if what if we want to do at specific position, means the number is 1, 2, 4, and we want to insert in the middle of the 2 and 4 3. We want to insert in the middle of 2 and 3, 2 and 4, sorry. So now we'll see the, see, head is pointing, again the conditions are same for the insertion uh, insertion at beginning, insertion at end, then insertion at specific position. All pointers are same, all the things are same. What we are doing is, first we are inserting prior, after that we are inserting afterwards, means at last, and then we are inserting at specific position. So we'll take the input from the user side, what is the specific position. Specific position means we'll take the index x value. So what are the index value you want to insert there? So we'll go there. After that, what we have done is send the current, means previously what it was there 1, 2, 4, and we wanted to add after 2, 3. So what we will do, this current, so third जो new node, this new node next is there, this will be pointing to the fourth data. So this is connected to the this. Now we will, what we will do with the 2 next, means this node current next we will connect to the new node data. So in the specific position we have to connect two things. The second, or we can say current, whatever the current is there, current means the uh, specific position. The current value we have to, current next we have to connect to the new node data, and the new node next we have to connect to the next, means fourth one, means after that third in middle, after that, that we can say node data, or we can say temp, because we can use a variable temp here. So now after this, see, after this maybe, yeah, so this two arrows, what I was talking about previously, this two arrow got inserted, means this got here and this got there. So they got attached, means both are connected. Now it will come. See. So at position 0, 1, 2. So position 0, 1, 2 at index 2, position 3. Position 3. Okay, good. So after that we'll go to the search part. So what if we want to in a linked list? In a singlet linked list, just like 1, 2, 3, 4, 5 or 10, 11, 12, 13, 14, or 2, 5, 8, 7. So see here key value is 5. You want to search 5. So what we will do, we will traverse. So before searching, we need to learn about traversing. Traversing means going to each node. Going to each node means what we will do, we'll use two pointers, that is head and temp. Head will be staying there, but every time the temp will be updating till temp becomes null. See, this is head. Now we will make this as a temp. And how much time we will run till when the temp become null, means till the last pointer. So from first to last we have to make. So from starting from the head till temp, and temp next we will do till the null. And whenever we will do one if condition, that if we find this key value, whatever the key value user is providing, if we find that key value, we will, in the case of here, we I think so wait, so this is traversing in searching. In the case of that searching, see, the key value is 5, so we will traverse every node, and if we find the key value, we will return it, or we will return true, or we will return that value based on the condition or based on the code. Okay, so traversing is like going to each node, and what are the conditions for that? So we'll take 2 pointers, and the second pointer will go till null, and we will what do, will temp is equal to temp next. So this temp variable will be gone to every, after this it will go to next, the next, the next, and it will go till null. So now we'll talk about the last thing, that is deletion part. If the node is there, and if you want to delete some part or some single node, so in deletion also similar to the insertion, there is three types: insertion, deletion at end, deletion at beginning or first, deletion at end, and deletion at specific position according to user. So currently we are looking on the deletion at the beginning. So in the beginning, what we can do, we can directly use this head part. So the whatever the thing is, uh, whatever the head is pointing to, we can directly delete that, and we can update our head to next pointer. See, this pointer, this node is head is pointing to this node, so we know head is pointing to this node. So what we can do at the beginning, we can directly delete that head part only. See, 1 2 3 4 is there, and if you want to delete head, see, head was pointing previously to 1. So what we done is, for deleting 1, we just updated our head to 2, means our second node. So if we updated our head to second node, means first node is not pointing, the head is not pointing to first node, means it, after this we can remove this, we can free this, we can delete this. Okay, this is as simple as that. And for the big so this now head is pointing to 2 3 4 and null and all the specific, done. So this is simple, just we have to update our head at the deletion at beginning. For the deletion at beginning, we just have to update our head, that's all. So after that, when we go to this deletion at end, means we know this head is there, 1 2 3 4 5 null, 1 2 3 4 null. So what is there like input? See, so 1 2 3 4 5. Now if you want to delete at end, how we will delete? See, here also at end is deleted, so we'll see here. So 1 2 3 4 is there. After that, we want, so the current head, for this we can directly do, but for the deletion at end, the current we will take this one, means one prior, one previous, the current, and then current next, or current, this current is pointing to the data of the next pointer. So what we have to do, just like we have updated this head to the next pointer, now we will update this next pointer to null. So this is not existing, because we this next pointer is directly, we updated to null, so there is no existence of this node. So now after this we can delete, we can remove this node. This was the only case. So now it's 1 2 3 and null. So for the, at the beginning we have to update our head. At the last, if we are doing deletion at last, so prior to, we have to consider one current, and we have to update the current next is equal to null, current next arrow to null, and that if we put in that arrow, means that 4 is not existing, because current next is null, because you know, the node ends when the last node next having null value, and the last node next having the null value, that's why it's not existing, so we can delete after that. Deleting at a specific position, so we need to get the, what is that position, so we'll understand. See, this is the current, now we want to delete this. How we can delete this is, so there's two things we can, so current next, if you want to delete this, means it's just prior for this, and for the next, means in the middle, if you want to delete 3, what we have to do, if we can connect 2 and 4, means if we can connect the node 2 and node 4, means there is no existence, means it will not there because we have connected 2 and 4. So what we have to do is we have to connect this next, that is node 2 next to null, means node 4 4 this 4 we have to connect. So next means we have to current next is current next arrow is data of this new of this node, and this node is obviously going to null. So deletion at the specific position. So this was the thing. If you want to visualize, you can visualize. This is a repo I found it. So what if we want to insert? So we want to insert at index 1 and our value is 18. So see, so our value got inserted. So this I want to add my data. So it will see going to 18. Now data 45 added. So we'll add one more, that is 32. We will add one more. 45 is going to 45. Now it's 32. Now 32 is pointing to null. Here we can see 1, 18. So 1 is pointing to 18. Now 18 is pointing to 45. 45 is pointing to 32. And 32 is pointing to null. What if you want to remove? And choose the option to remove null. Okay. So we have to choose. Okay. So which data you want to or indexes? So we can put we want to remove 45. So how it will remove? So it is in deletion at specific position. See, specific position is deleted. Now what if we want to delete our deletion at beginning? So deletion at begin. So it directly head got updated to here, means 80. So we'll add some more elements for the for next examples. That is, let's add 25. So we'll add 32. 32 is pointing to 25, and 25 is pointing to null. Okay, so what if we want to add insertion at specific position? So this is the index 0, this is the index 0, 1, 2. What if I want to add between 35 and 25? 32 and between 32 and 25. So 18, 0, 1, 2. So I want to insert it at position 2, and let's the number be 18 only. Let's see what happens. So it's going to 18, then 32, then okay, so it got updated. So if you want, you can try it by yourself also. Now we will move to our coding part. So we are I will just show you my code, what we have done in the project. So basically this is my Visual Studio. So I'll explain you just the raw code of this, and after that we will sum up. So this is purely in C, and we are using linked list. As I explained you about linked list, what is linked list, and in this we have used the concept of singly linked list. In that singly linked list, we have done insertion, deletion, search, then print, and traversing, all that stuff we have done. So we have taken the real world example or real world problem, as I told you about student management system. So I'll explain you line by line fastly. So we have done some. This is library. If you are familiar with C, these are some libraries. Define max, and we have defined one structure for the student. In student, what we are taking roll numbers, we are taking name, ages, and course. What are their courses? So basically, these are the things. Then this is the add student. So first we have this add student, means this is the insertion part. This whole is the insertion part. View student means we can search or we can any searching part is done in view student. Search student, view student if you want to find the student. So search student, view student, add student. One second. So add student, view student. Now search student, update student. So we if there is a thing that in code we have to optimize, means we are adding students. Now we want to update, means we have to add our student, one more student or the existing student. We have to update the data, means after the birth date or the roll number or anything, the data we put in is wrong, so we want to update our data. So there is a update student function. These are all the students function. There is a delete function which already we talked about it priorly. Now we have given some choice: add, view, search, update, delete, exit, and enter choice. So let's see if program is executable. I'll try to execute program. Let's see, it's taking too much time. So till now we can do something here. So we can do some we'll do something. We'll visualize. So 34, add 34. So in this add function, just adding linearly. If you want to add a specific position, this add means this is adding linearly. If you want to set data for the removal also, we can use. What if we use indexes? Means what's it doing? Okay. So what if you want to by indexing? No. Now by data I want to remove. What if by data I want to remove? I don't like this 25. So I want to remove this 25. Let's see. So it's going 18. Now this, so it is between two. So this two node got jointed, means this two node, they got this this pointer got connected with this data, and this the previously there was one node and that got deleted, so it was deletion at specific position. Let's see if our Visual Studio is launching a code or not. Okay, we are got some console, so now it's not running. Okay, this was the only code. If you want, I will give you the repo. The repo is in description box, or we can find. I'll give you my GitHub ID also, so you can find there. This is code. I don't know. Now it's not, why it's not working now. It's working, although it's not able to run. I'll figure out. But if you want, you can use this code. I have already put in repo on my GitHub, so you can check on my GitHub. That's all. Thank you so much.